Okay, moving right along. Our next presenter is Dan Bedford. He's a professor at Weber State. And I must apologize that I spelled your name wrong. It's Bedford, not Benford in the agenda. So my deepest apologies. So he's going to present about landscape and temperature in Ogden. So please welcome Dr. Bedford.
Thank you very much, Adam. No worries about the typo in the program, not a big deal. Thank you very much for inviting me. It's a pleasure to be here. Thanks, everybody, for your time and attention. My name is Dan Bedford. I'm a professor in the Department of Geography, Environment, and Sustainability at Weber State. And I'm going to talk to you about landscape and temperature. This is the results of some research that I conducted over the summer, but also going further back in time, a fairly kind of lengthy stretch of time I've been working on this. Now, I may well sound like I'm not from around here originally, and that's because I'm not from around here originally, but I've been living in the Western US for over 30 years, and I married into a family that has deep roots here. My mother-in-law grew up in Ogden. I think her great-great-grandmother lived in Fort Buenaventura. So I've got a really strong, I feel like I have a really strong connection with the landscape of the Western US, and I love it here. This is why I've chosen to live here. One of the issues, though, that is cropping up for me is that here in the Western US we find ourselves in kind of a tight spot because on the one hand, obviously we have a water issue, right? And we wouldn't all be here if that weren't the case. So we've got to worry about conserving water and do everything that we can to ensure that we're not wasting water and to be mindful of the fact that our supplies of water are shifting and changing as the climate changes. So we've got to be having water front and center. But at the same time, we've got to be careful about how we go about our water conservation measures, because if we change the landscape without being thoughtful about it, we can bring ourselves a whole nother problem, and that is increased temperature. Because as a gentleman I know in Ogden City pointed out, essentially when you've got turf, you've got water, and that means essentially you've got a swamp cooler. You take that out, replace it with xeriscape. If we're not thoughtful about it, then we can give ourselves this whole issue of increased heat. So that's what I'm going to talk about, is this issue of this, just trying to strike this balance between saving water without getting ourselves into a situation where things get really hot. So let's get into that a little bit. First of all, this is a graphic that shows an urban heat island for Washington, D.C. This was measured in August 2018. The urban heat island concept is the idea that urban surfaces tend to get much, much hotter than the surrounding countryside. And if we go back and forth between a satellite map and the heat map, you can see there's some pretty distinctive patterns showing up, right? You can see that the green space, Rock Creek Park in particular, shows up as a lot cooler. Anywhere where there's green space or water on the map ends up being a whole lot cooler. And the big paved areas get a whole lot hotter. Everyone seeing that okay? So the reason for this, well, there are multiple, and this is well established, is we've got things like city geometry. If you've got lots of tall skyscrapers, then you get sunlight reflected down from the walls down to the surface, and you've got more surfaces to act as radiators in the evening to send that heat out into the air. Human activities, of course, driving around, we generate heat. No building is perfectly insulated. As I know, every time I get my gas bill from Dominion Energy, my house is not perfectly insulated. So it's bleeding heat into the surroundings. Artificial surfaces have heat-retaining properties. They soak up a lot of heat during the day and then they radiate it back during the night. And urban surfaces often lack water. We take out green space and we pave it over and we put in big parking lots. And for the same reason, we lack vegetation. So all of these things will work towards making things hotter and mitigate against making things cooler. And this is just to demonstrate this. This is a photo I took during the pandemic lockdown, actually, just outside my house. And this is taken with a regular camera and then with an infrared camera. We've got three different surfaces here. We've got the light-colored paving stones, we've got the grass, and we've got the road. And you can have a quick, just mentally guess which one you think is going to be hotter, which one is going to be the coolest surface. And the hottest surface is indeed the road, which makes sense, right? Because it's dark, it's going to be soaking up lots of sunlight, but it's also really dry. So all of that soaked up energy is going to go into raising the temperature of the road. If we got water on it, then that energy would go into evaporating the water, not raising the temperature so much. Interestingly, though, and this always throws students because they think, this bit, oh, that's going to be coolest because it's lightest in color. It's going to be the most reflective, so it's not going to get as hot. Actually, no. Even though this surface is a bit darker, okay, not as dark as the road, but a bit darker than the light-colored paving, that surface, because it's got so much water in it, is the coolest surface. You might, if you're particularly observant, you might also notice this little patch over here, the dry grass, right? So some significant temperature changes there. Now, all of these ideas of city geometry, heat from human activities, heat-retaining properties, water and vegetation, all of those things contribute to the urban heat island. We can influence some of those things in our individual choices when it comes to the landscape that we choose. So in investigating this is some work I did with students quite a few years ago. Actually, I worked with Drew up at Weber State, and we were looking at how hot some of the different landscape surfaces got that the landscaping folks were looking into using for xeriscape purposes. And we measured the surface temperature and compared it against how much sunlight we were getting. We had a weather station measuring the amount of sunlight as well, so we could compare the two. And what this graph is showing is that's solar radiation, the amount of sunlight running along the bottom, and this is how hot the surface gets running along the side. And the road, well, as you'd expect, it got pretty darn toasty. With a lot of sunlight, it's going to get good and hot. But compare that against rocks, the light-colored rocks over here. Because they're lighter, they're more reflective, they're not absorbing as much sunlight, so they don't get as hot. So if I go back and forth, you can see the difference. 100 watts per square meter of sunlight translates to 3.6 degrees Celsius of warming for the road, but only 3 degrees Celsius of warming for the rocks. But compare that with the next surface, which got crazy hot. In fact, some of the student measurements were so high that the class started questioning them. It's like, no, they must have done that wrong. They measured in Fahrenheit instead of Celsius, or they took a misreading. No, actually, we were very careful about it, and we got exactly the measurements. That's really what the temperature was. In fact, it was getting so hot that students were reporting that some of the undersides of some of the plants were getting scorched. So it can make a big difference what you choose to xeriscape with, right? Compared with road versus dark wood chips, there can be a pretty big temperature difference. Now, the most recent research I've done on this was over the summer, where I took a series of these things. These are eye buttons. They're tiny data logging thermometers. You can program them to take measurements of temperature over however long a time period you want, so long as the battery lasts and the memory lasts. And I had these programmed to take one measurement every hour for the entire summer, last summer, and I had 50 of them, and I placed them in locations all across Ogden, working with folks at Ogden City who are incredibly helpful. So thanks very much to Ogden City folks. I think I see one or two of my co-conspirators out there in the audience. So these little things, fun things to work with. A few quirks that they have, though. If you put them in direct sunlight, then they're going to give you a false reading. So compared, eye button thermometer compared with a properly calibrated professional grade weather station, it's giving us too hot a reading. So I had to do some thinking and futzing around to make sure that the eye buttons were properly shielded so that they were actually measuring the air temperature, not simply measuring how hot they got from being in the sun. And it turned out that although there's lots of different complicated ideas being suggested in the scientific literature, we found that if you just wrap them in foil, then it works pretty well. Unfortunately, it's not perfect. I did some more tests and found we haven't quite cracked the problem, but we're pretty close. So I wrapped my 50 eye buttons in foil and spent a number of days placing them around Ogden back in June, and then picked them all back up in September. And I haven't really had a chance to crunch all the numbers yet, but I'm going to show you some of the preliminary results. These are some of the places we went. I worked with a number of different community partners, as well as Ogden City. Catholic Community Services were incredibly helpful out in West Ogden. And I placed an eye button That's that one covered in foil with a higher end thermometer, so I could do some calibration work, which I haven't actually done yet, but this is preliminary results. Here are some of the sites that I placed iButtons in. This is in West Ogden Park, up in a tree, and you can see how inconspicuous these things are. I will give a sizable prize to anybody who can spot where the iButton is. It's there. It's really hard to see. Close up, it's still hard to see, but that's it. Right, so these things are pretty inconspicuous. So they're good. They may not be perfect. They're not high-end. They're not expensive. But they're really great for this kind of work because you can put them out in places where the public goes, and it's, A, going to be really hard for people to see them, and B, it doesn't matter all that much if you lose one. But fortunately, I didn't lose any, so that was great. Here's another site. This is Observatory Park in West Ogden, and this is where I put the iButton, right there. So it's getting a good distance away from the ground. It's actually measuring the air temperature. In urban climatology, you often have to go with what the circumstances provide you. You can't always be perfectly the same height above the ground and exactly the same circumstances, but that's just the nature of doing urban climatology. And nevertheless, you can learn some interesting things. And I think what I was getting from the iButton work actually was pretty interesting. This is comparing the West Ogden Park site, this one, and this is averaged all of the hourly measurements by hour for the 15 hottest consecutive days of summer 2023. We were pretty lucky this summer, I thought. It wasn't too crazy hot. I mean, not compared with the previous few summers. But we did have a couple of weeks in there at the end of July where it got pretty darn toasty. So it's those 15 days that I'm looking at here. Average the measurements for each of those 15 days, and that gives us a sort of average temperature curve over the course of a day. So coolest at over here about 6 in the morning, and hottest in the kind of mid-late afternoon over here. So that's the site that the iButton was in right there. And compare that with Observatory Park, and there's a pretty big difference. Right, so that's in a green space, and that's in a much less green space. This picture is actually a little bit misleading because the picture of Observatory Park, because when I went back in September to collect the iButton, it was dry. So it was still fairly green because of the spring snowmelt and such a wet winter that we'd had. But that was a space that was really pretty darn dry. So some quite interesting differences there, especially when you consider that this is averaging. So those differences are really quite meaningful and quite substantial. Even more interesting is when we look at a residential site that was quite close to West Ogden Park, this location. So pretty good actually in terms of trees, but not a whole lot of shade, especially when you think about how wide the streets are. And if we zoom in on the warmest time of the day, then the differences here between the coolest place, which is West Ogden Park, well watered, well irrigated, lots of grass, lots of trees, and the residential site that was just down the road, that amounts to roughly 5 to 6 degrees Celsius temperature difference. That's getting on for about 10 degrees Fahrenheit. That's a big difference. I mean, that's something you're really going to notice, especially if we're talking about communities who can't afford to run air conditioning, who don't have air conditioning, maybe who don't have the privilege of secondary water that they don't have to pay for. You know, all of these factors are going to start playing into how people experience extreme heat during the summer. So I guess when we take this up to the neighborhood scale, this is also, again, some preliminary results. If we look at comparing downtown Ogden with the East Bench, those differences start to wash out a little bit. They're not quite as substantial, but that's because we're looking at a larger spatial scale. We're looking at a difference of between about 1.5 and 2 degrees Celsius at the hottest time of the day. And only a little bit of that can be explained by the fact that the East Bench is higher up and downtown Ogden is lower down. Not all of that by any means can be explained by that altitude difference. So a lot of this is going to be landscape difference. The fact that we've got more trees, more green space, more parks, better irrigation, better watering, secondary water up on the East Bench compared with downtown. And again, if we zoom in on that hottest time of the day, you can see those differences a little bit more clearly. Now, these issues of landscape and temperature are being taken seriously all across the country. And Salt Lake City did a big study just this summer, where they engaged in citizen science. They fitted thermometers to cars and drove around various parts of Salt Lake. And this is part of their results. They've got a very extensive report that just came out, which I haven't read all of yet, but some of the maps are quite striking. And they're finding again, really substantial temperature differences within the heat island of individual cities. So this is an issue that we need to start thinking about. And just to remind you of this image with the cool grass and the hot paved surfaces, and again, this double bind that we find ourselves in, right? On the one hand, we've got to save water, but if we're not careful about how we save water, we can give ourselves another problem, which is increasing temperature. So I would conclude by saying that it's important to rip your strip. I think these rip your strip programs are really smart. They're good ideas. They seem to be really effective. So the rip your strip seems like a really good way to be saving water. But it's also important to think about what happens afterwards. One of the things they're finding in Salt Lake is that communities where strips have been ripped, people forget to water the trees. And the trees are really important for cooling because they provide shade. So we've got to be smart about how we save water through individual household landscaping decisions. That's where I'm going to close. And I guess if there's time for questions, I'll take a question or two. Thank you.
Maybe do one quick question right here.
You say to go to xeriscape is there any recommendation? Are there any recommendations you have about what we put in the xeriscape as far as colors and so forth?
Yeah, that is an excellent question, and I'm going to dodge it by deferring to my colleague, my next speaker, Stephanie Dewar, who I think will probably be hitting on exactly these things. Who is far more of an expert in these kinds of issues than I am. Or Drew, maybe. Where's Drew? Right there. Got any ideas, Drew?
I think purple, yeah. Go.
Oh, yeah.
No,
purple and white. White would be good because it's reflective.
Yeah, that's true. What we have done in facilities at Weber State was taken this information and tried to not stick with one kind of xeriscaping or another. We've mixed in rock, we've mixed in mulch. I think that just being more dense with your planting will probably help with that.
Yep.
But that would be my 2 cents.
Really quick. Is it quick?
I have a really quick question, Dan. To what extent is a tree a positive because it's shade or a negative because it's evaporating? How much water does a tree really take? Because I'm watching a lot of people putting in trees still, even though it's xeriscaped, and I'm thinking, how much water is that maple or that scrub oak or whatever it is they're planting, how much is it going to use?
Yeah, again, great question and a little bit outside my area of expertise. So this may be something that Stephanie or Drew have more to say on. But I would imagine that A, it's probably going to depend on the kind of tree, but B, my kind of non-plant expert perspective, my kind of physical climatologist perspective, is that trees tend to be, again, depending on the kind of tree, they can be pretty water efficient forms of cooling, actually. But plant experts may have more to say on that than I can throw in. There was a bunch of hands.
There was a lot of questions. Just in the interest of time, Dan, are you going to be around?
Yeah, I can stick around for lunch.
Okay, so I'm so happy that I have so many questions. But yeah, just in the interest of time, we're just going to keep moving on. Sorry.
Thank you.
One more round of applause for Dr. Bedford. Thank you.